Good afternoon, gentlemen. Uh, Gentlemen and ladies, if I know there are a few of them. So, hi, this is Jay from M76 Analytics. We are speaking at this webinar being hosted by 10XTD on demystifying decision science. The entire journey of decision science, in fact, uh, science is also an art. In fact, mathematics is also an art in many ways. And Bertrand Russell once made a very important statement. He said, "Mathematics possesses not only truth, but supreme beauty, a beauty cold and austere like that of a sculpture." And actually, that is exactly where the word sculpture leads into the fact that it, the truth that is supposed to emerge out of the mathematics may not just be a simple sliced and diced number. It could be different. It could have a shape to itself. It could have a path leading to itself. Therefore, it has to be sculpted out. It would not just be one data model being imposed on my entire data set and that giving me some sort of a report. So it is the creation of the sculpture, the sculpting of the sculpture, which essentially decision science is. And that's where we are starting with the statement. So very briefly about ourselves, M76 Analytics, we're a sign ID Bombay company working primarily in the space of giving strategy toolkits and templatized strategy. And we get into the subject straight away. When does your decision science journey start? So here is a typical question, which anybody who heads sales, either it be a bank, a mutual fund company, an AMC, or even a realtor, anybody who heads sales, B2C sales, typically has questions like this. The question that we've just put up here on the screen, that our sales shoot up every March, as the distributors ramp up their game to meet the deadlines. These distributors could even be your, direct sales representatives of banks or, the last mile channel partners. They could be any of them. But, are those numbers worth being celebrated? Because many times, even if you look at the case of several pharmaceutical companies, what tends to happen is that the salesman, to get his bonus, pushes a lot of stock, the pharma stock, on the distributors, and it's not necessarily consumed at the retail endpoint. So after a while, the distributors, have to send the stock back, and the sales has to be marked down. But invariably, the salesman makes his commission and pushes away. Now, there are several of dimensions, tens of dimensions. What is the geography? What is distribution channel? What is the particular product he's pushing? Was there a leeway to have more sales commissions for downstream members in that product, in that particular sales scheme? We do not know. There are tens of dimensions to do so. And if you're a large company, you might actually have crores and crores worth of transactions. Even your individual transactions, if you're something like a deposit scheme, your individual transactions could start as low as 500 or 5,000 rupees and could even go to a lakh or a crore. How do you now get the black sheep out? Your standard reports, they might just not help you to drill down beyond 2 dimensions. Often, the very effectiveness of the salesman might need a computational number which extends across each of the dimensions, and they could be 7 dimensions, 8 dimensions. How do you then go about saying which are the black sheep, which is the needle in the haystack? If there are many needles, how much have they actually contributed to my decline or to my gain? How do I go about assessing all these? And this is exactly where decision science comes in. And this is exactly where reporting hits its limit. It can't go beyond that. A lot of the traditional analytics, which is often dependent on visualization, also hits its limit there. It can't go beyond that. And that is where decision science comes in. So typically after decision science, the manager would come up and say, "Oh, wow, this is the right way to measure my business." Though we knew this well, I had a hunch that that distributor is not doing well, but we never had the dexterity, the ability to move our arms, move our hands, and the freedom to map our structure and say, this is the decision making process I actually need. And decision science actually contributes to making the decision making process standardized and templatized within an organization. So typically, what would be the characteristics of a good decision science solution? Uh, Rather than a lot of standard BI or MIS reports, the decision science solution would deal with trying to get process endpoint estimations. Now, what are process endpoints? Process endpoints are like you've moved, you're a logistics company, you've moved inventory from location A to location B, or suppose you are an FMCG company, that makes things that do have an obsolescence timeline. For example, you make a toothpaste, yeah, or you could even be making some sort of a lotion, right? Now these have timelines for obsolescence, and at the end points you hit an obsolescence cost if it is overstock or over indented, right? You suppose you are a bank, yeah, and you have several customers who are actually coming onto your phone lines or IVR systems and asking for help. You need to plot their life cycle, because you need to know that customer of so and so demography is going to be with me for so and so time, and therefore this is his life cycle value. So anywhere where there is a process endpoint to be estimated, that's where a decision science solution would kick in. I mean, these are just a few examples, but you would really want to know that if these are the 3 or 4 problems you're trying to solve, you need to go beyond BI. You need to go beyond the traditional visual analytics. You actually need a decision science solution. Strategy support. Yeah. Now, how do I choose based on my channel costs and based on the sort of basket of goods that is sold in a particular market? What should be my distribution design? That again would come out of decision science. And believe me, these are very, very complicated techniques. Many of them often involve Markov chains. Even designing a Markov chain, designing a transition probability takes a lot of transformation on your standard transaction data. That is when it is actually enabled to be able to give a decision to you. Sustainable operations, throughput, marketing ROI, service level management. This is a beautiful case, which in fact most organizations should actually be doing. Let me give an example of sustainable operations. We started our journey way back, working for uh, uh, a re-commerce site in the United States. It's not e-commerce, it's re-commerce. Re-commerce means the trade in second-hand goods. So this was a site trading in second-hand mobile phones and electronics. And they spent a lot of money on marketing, which was through advertising on various networks. Now, the United States is not an easy market. You have at least 4 time zones operating in the mainland United States. You have a lot of TV networks. It's a very diversified market. You have a lot of TV networks which switch between local broadcast and national broadcast. And for each one of them, the advertising spot rates are different. So how do you get the whole thing together and say, this is the ROI on my advertising expense, and therefore this is the constant customer base which is being created for me, at least 10,000 or 12,000 visitors per hour or per day. And based on that growing organic customer base, now look at the various layers of decision science. You first estimated what is the actual ROI on marketing in terms of number of visits. You're going to the next level now. You're saying, what is the sustainable growth in my organic base, so that after some time, maybe I don't need to market. So you need a full sustainability decision support system. That's again something decision science would do for you. Revenue enhancements, these are the lowest hanging fruits. People look for propensity models for cross-selling, upselling opportunities. In fact, these are some of the most simplistic applications of AI and ML. But given the limitation of the market in terms of knowing business processes, in terms of knowing complex decision modeling, these occupy most of the mind space of the market. So typically, if you were to approach an AI ML firm, the first thing they would tell you is, oh, we're going to do pattern classification. We're going to tell you where to cross-sell, where to upsell and enhance your revenue. And because it's about revenue enhancement, it's the lowest hanging fruit. But we need to be careful. We need to disabuse our minds that this is not the all of decision science. Perhaps this is a fraction of it. And I'm not underestimating by using the word fraction. It is actually a fraction of the whole gamut of things that decision science can do for an enterprise. So typically, what would decision science need? It needs experienced business consultants. I mean, you don't really need the McKinseys and Andersons, but you certainly need people who understand business process at the least, or at least have worked in some form of enterprise solution to be very conversant of a business process, be cognizant of where business processes can fail. They need to be adept at all of stats, a lot of operations research, and a lot of economic modeling. So please, 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 even if you go and do some course on the internet, there are plenty of courses saying this is the next AIML course, this is the next decision science course. A lot of them available on the internet. I don't want to name them, but believe me, they would only take you through a fraction of it. Most of them tend to take you through a standard guideline of what machine learning is, a couple of the applications that are already established, and that would be the end of it. Actually, it needs all of this for you to be able to really give out a good decision science solution. And we should have a capability to platformize the big data solutions. What that means is you're not just going to do it once, generate a report, and go away. You are going to give the power in the hands of the user that he plays with the data again and again, and then is able to take strategic decisions. That is clearly what the market is looking for. And that is where actually, I believe most mature product companies in the decision science space should be headed for. So quickly, a summary of decision science versus the traditional business intelligence or analytics. It's the traditional BR analytics starts with data as prime. In a sense, they say, here are the established star schema, the other sort of schemas of data warehousing. These are our reporting data structures, and we're going to start from here. And let me tell you which are the couple of points I can aggregate, slice, or dice and give it to you. In a sense, it's not starting from the business user's mind to take a decision. The transaction reports have generated certain data structures, based on certain temporary reporting requirements, and these are simply, I would say, spot reporting requirements. Okay, what is the number of purchase orders rolled out today? Okay, based on the number of purchase orders rolled out today, how many of them have goods been delivered? How many of them have been invoiced? These are based on spot. I use the word spot reporting requirements. These reports are not necessarily based on the way management would like to think or take decisions. Come on, the decision science, on the other hand, it actually starts with business value streams. I don't know how many of you heard of value stream mapping, but value stream mapping is the base to start decision science. It starts on the business value stream and then says, okay, to get the best single number saying this is the health of my business process or my business value stream, this is what I need to do. Decision science starts there. In a way, though pretty amusing to say, but decision science quite starts at the opposite end of where BI or traditional analytics would start. Decision science, the traditional models of BI would be based on roll up, roll down, slice and dice. The decision science approaches would be based on actually finding the right solution technique. So, am I trying to say that on my shelf, I'm trying to estimate the inventory at the end of every week? Okay, for that, what sort of distribution do I need to study? Is my transaction data from the point of sales currently even enabled or transformed enough to help me come to this answer? So decision science actually starts from the other end. So we go back to Bertrand Russell's definition. It's about sculpting. So you have to be careful. It's an art. There is not going to be a one-size-fits-all solution of decision science. It's like an art. You'll have to sculpt out the solution first. In typical initial outcomes of a BR analytics system are post-facto analysis at predefined levels of information hierarchy. In decision science, you typically first tend to start with some sort of a root cause analysis. You have some behavioral insight. You know that, okay, if 8 out of 10 people come to my website, I'm an e-commerce company, and give me a not so friendly rating, they're perhaps giving it because the transition time between pages is longer, my e-commerce cart did not work properly. You get a root cause. And you have some behavioral insight. The most important insight discovery of decision science is parameter sensitivity. You're actually trying to find out how does parameter B change if I vary parameter A by X. And that sensitivity actually forms one of the cornerstones. It's the foundation of a sort of decision that management would like to take. These sort of sensitivity parameters are completely missing in the traditional business intelligence or analytics solutions. Medium-term outcomes in a typical BI solution is, okay, you have insights up to the last grain because you've built the model, you got it there. In the past, you would have all the KPIs and metrics that you would have want to calculate. You have all the slice and dice across different departments. But so this is more like a what is happening, what has happened is what traditional BR and analytics gives you. A good decision science solution would actually tell you the whys. It would generate a reason space. It would say that, probably because of this accounts for 20% downfall in your sales. It would give you a needle in the haystack capability. It would actually tell you it would help you narrow down and say, this is the last culprit, or this is the best contributor to what I'm getting today. It would even quantify errant behavior. So it would even say that this particular department or this particular division in the future is likely to contribute to a 20% downfall in my EBITDA. These are the sort of answers decision science gives you, and these are the sort of answers BI would give you. That's why you typically find still, if you go to a lot of medium-sized industries, you find the CFO actually trying to put together several MIS reports, and he will tell you that, I'm spending 15 days a month taking all these Excel sheets, putting them together and trying to find my answer. Finding his answer is typically this decision science job, which is currently not automated. So one term which we would now like to introduce is the fourth industrial revolution, 4IR, as it's popularly called. Now, the first industrial revolution came with basic mechanization or automation of processes. It used water and steam power. The second one used electric power to produce mass production, which was your cars and the automotive industry. They heralded the second industrial revolution. The third industrial revolution actually used electronics and IT, information technology, to create a lot of automatic and sequenced production processes. The fourth one, which is currently being called, uses on the current one, brings in robotics, brings in artificial intelligence, brings in a lot of physical and digital interconnections along with the biological spheres to create a new type of production plan. That's the fourth industrial revolution. And a decision science, because it leverages all the other sensors. Let's look at it this way. In the fourth industrial revolution, you're going to have robotics, you're going to have a lot of automation, you're going to have a lot of sensor data, which is going to be collected from various places across a refrigeration, across a process plant. All these come together. These data are like a sensors, while your decision science system, is going to be the brain. So this data is going to be like a nervous system, right, which is going to collect all the data. Once collected all the data, it's going to look at the responses you're going to make. So it's going to produce an automatic reflex back. That sense and response system will be enabled by the fourth industrial revolution. Decision science will be the brain power. It will be the brain of this sense and response system. Therefore, these are the 4 R's, as we say, to consider before you jump into the fourth industrial revolution. And these 4 R's pertain to decision science. They are getting the right metric pegs. As I said, is it the EBITDA which is the right metric? What is the right metric the management looks at? And most often, believe me, gentlemen and ladies, the right metric will not be available to your visible or naked eye. You might actually have to create it. For example, if you're going to say, how do I know the month-on-month decline of my 3-year revenue value of my customers? That metric is not going to be available to you out of any of the standard reports. You're going to have to create that metric. You need the right metric pegs. You need the right business value stream. As I said, is your business value stream manufacturing? Is your business value stream management overhead? Is your business value stream sales overhead? And often, just the way you constructed the metrics, you might even need to construct the right value stream you're going to attack. Then you need the right investigation. Right investigation is, what am I trying to check? If I'm a bank and my sales channels have bought in some bad home loans, am I trying to get to the last sales guy who got them? Am I trying to get to my channel which recruited the sales guy? Am I trying to get to my geography? Am I trying to say this geography will perform poor in the future? What is the investigation I need to carry out? You need to know the right investigation you're going to carry out. You need the right numeric techniques. And as I said, the standard AI and ML techniques may just not help. Often you might use some operations research optimization algorithms. You might use a lot of econometric modeling. Econometric modeling is a science forgotten, but I think it's time for a renaissance now. It should be back. A lot of econometric modeling was used by the planning commissions of India when they made India's 5-year plans. And they actually used sensibly a lot of data the government used to collect to say, after the 4th year now, in this sector, say cement, we are going to see so much growth, and therefore this sector needs so and so type of impetus from the government side. Now that a lot of data is available, similar modeling techniques could actually be used even to plan your further market strategy. So a combination of all these numeric techniques is what again constitutes good decision science. So very quickly put, you take these techniques, yeah, you templatize them on a platform. See, after a certain point of time, your processes are going to stabilize. You would innovate on how you do decisions, but your processes of how you compute those numbers, how you transform the numbers would stabilize. So you sort of typically templatize them on a platform. When you put these two things together, you get a good decision support solution. And this is exactly what the Harvard Business Review predicted way back in October 2013, that there would be scores of startups and some incumbents who would explore the possibility of using that technology and big data. Only a limited number of consulting jobs can currently be productized, but eventually the startups will produce an intellectual property in this space. And that would lead to further automation and technology products. This is exactly what decision science does. So how do you approach a decision science problem? You actually start by setting up your insight. What is the type of insight you're actually looking for? And here, the traditional MIS or BI actually serves as the starting point. So let's take an example of a company, which would manage a lot of logistics. We're working with a company which manages a lot of logistics, moving vans of goods across different locations within about 16 cities. Now these are precious goods, so there's security with those vans, right? There's a cost of the security guard, and there's a cost of moving the van. There's a cost of the salary of the staff, of the boys. A very simple point. Nothing to do with hi-fi, AI, and ML, but an extremely burning issue in the market, especially with those who manage a lot of these logistic companies. The management would come back and tell us that there is, only at the end of the year, insights that we have as to what is the actual cost of the vans and guards that has taken place across all the different locations. And that badly impacts the EBITDA, but we don't know anything about it in advance. We can't do much. Yeah. Now, the solutions for this are somewhat simple, I would say intelligent, but not available in any of the current product forms, and therefore they form a decision science space. There is a need to collect data from different locations, suitably transform it, and predict what will actually be the consumption of guards in the future, what will be the fuel cost of vans, and then say, now this is the prospective EBITDA you're looking at, and these are the areas you need to take, you need to have a correction so that your EBITDA does not go down. Such an important application. And believe me, a lot of these applications are often nightmares for the finance division or the chartered accountants who are working in the company. But so important. But they have some sense of sculpting. They have to, the application has to understand what the EBITDA would be computed like, what are the future projections that need to be made using artificial intelligence. That is where the sculpting part comes in. But eventually it would get platformized. So what is the insight setup? What is the MIS? What is the starting point of the MIS? Where am I stopping? And after the MIS stops, where are the nightmares for my organization beginning? The second step in insight setup, as I said, is to decipher the value streams that matter to the leadership and the key decision triggers for the leadership. So when is the leadership going to get up and say, this is my early warning signal? This is my signals which says that my 3-year customer value is going to drop, it's going to fall substantially, and I need to penalize this particular sales channel which has brought in this customer. That ability to anticipate and calculate the right decision trigger. You have to know what is the correct calculation for the decision trigger, and that decision trigger calculation has to be communicated to the management in terms of a drill down. They have to be able to investigate to the last grain who is going to cause this bad business metric for me. So that entire insight setup has to be done first. Then you go into getting your North Star metrics right. Now, a North Star metric could often be simple like a tweak of the EBITDA, or it could actually be a fairly complicated thing. Let me give an example of what could be fairly complicated. Suppose you are dealing with a firm which trades a lot of commodity garments. Okay, it's a huge online trading firm, and you have a lot of affiliates and a lot of networks who are actually bringing customers to you. Now, in a particular month, say month April, how will you say that vis-a-vis month March, this was actually a bad month? You know, your overall numbers may have fallen or may have remained the same, but actually the market would have grown. So that's again bad for you, right? Because the market grew, but you did not grow. So that is one dimension. The second dimension is, you know, you had 500 people, affiliates, who are trying to sell for you, and all those 500 in the last month performed at X, right? But in the following month, some of them performed at 1.2 into X, some of them performed at 0.8 into X, right? Now, in that case, are they really good or bad? First, with respect to themselves. Second, with respect to the overall market. So this is the second dimension. The third dimension is you have different products with different profit margins, right? Now, some of the affiliates were selling product X, product A in the previous month. In the next month, they started selling product B, right? B might have actually been a low profit product, but they sold more volume of it and kept up their overall sales number as X.2 or X into 1.2. Did they do a great job for you? That's the third dimension. Now, you might have many such dimensions. And believe me, gentlemen, in the standard MIS or BR reports that you generate, there is going to be no metric which will actually help you assess the performance across multiple dimensions. And this is where the challenge of setting up the right North Star metric comes up. Second thing, these metrics have to be rationally predictive and forward looking. They have to talk something about the future. They have to take the behavior from the past and say, now, given this in the future, this is the way this channel or this process will perform. And that is where the line of investigation for the senior management would start. What you would have to do after that is you would actually set up the scenarios. Scenarios are mathematical formulations, okay, which actually help drill down or investigate into a certain behavior. So, for example, if you are computing what is the overall advertising expense based visitor coming to my website, and based on that visitor coming to my website, what is the overall CPC, the cost per click, right, or the cost per visitor that I'm going to pay, and based on the propensity of the visitor to actually do a transaction on my website, what is the further cost per visitor or cost per visitor for each transaction that I'm going to pay. So this detailing of the business scenario has to be done once you worked out the numbers. So until North Star metric, you work out the numbers, then you say, okay, now I've got the scenario. I'm going to investigate the scenarios. I'm going to see what's really going to happen in my company. Is that cost per visitor really worth it? Is that cost per transaction really worth it? And I'm trying to predict it in the future. Based on those predictions, I would try to set up alerts, early warning signals. Yeah. And then I would say, now I would want to have a line of investigation. So who is a particular geography, who is a particular channel, who is a particular advertising network, which is actually trying to get me these low value customers. And I would like to quantify the deviations. Yeah. So this is the entire management thinking, which is broken down into 4 steps. And this management thinking, leadership thinking, has to be the core of the decision science solution. So that's when it starts. And now you realize why, in spite of having several, MIS or BR analytic reports, there is yet a lot of requirement that the top management has. This is typically the areas from where the requirements come. So what would, a sort of an overall decision science solution, what would it look like? So enterprise arms, as I said, these are like the sensors. They're going to collect a lot of big data. Yeah. And the aim of all the effort and investment that goes into big data management and data analytics is to optimize the top line. Yeah. Bottom line and increase the overall profitability. That's all is the intent of any enterprise leadership. And therefore, the enterprise leadership must get early warning signals that pit them against benchmarks. This is extremely important. Very few tools currently offer the capability to pit something against a benchmark. And these benchmarks must be naturally calculated by the scenarios. So for example, going back to the same company which has trucks and guards and vans, right? You need to know that for you to be healthy, the overall expenses on security guards must not be more than X% of your total expenditure, right? Now, your scenarios must not just calculate them in the future, but must even benchmark and tell you this is where the deviations are coming from, because that's where you're going to make good operational strategy, right? There has to be a feedback on the overall health of the organization, yeah, and root cause analysis into the variations of enterprise health metrics. So, is this overall health of the organization changing? Yeah. Now, what do I mean by overall health? In the days of yore, when there was no automation, no ERP, and a lot of Indian enterprises were being run simply on the basis of the Khata Bahi, the simple reporting books, right? Yet, senior managers, especially leaders of organizations and founders, had the ability to tell their accountant, look, give me these three numbers at the end of the day, and I know the company is working well. And the accountant was simply good at it. He had mastered that skill completely. He would say, sir, ye number ye hai, this is this number, and your company is doing good. Now, with the amount of complexity of processes, but with the abundance of data available, there is once again the need and the demand, I would say, to compute those numbers scientifically and give them to the management. That, okay, these are your three numbers for the end of the day. So you're really doing good. So, for example, if it's an FMCG company which is thrusting a lot of inventory into the market, a lot of lotions, toothpastes, creams, that all of them have an expiry date. You can't keep them beyond a certain date. As well as there is known demand for all of them. So this company is going to say, okay, if my demand over the next 3 months, which is maybe my production cycle time, is X, and my inventory in pipeline is Y, and if X by Y is less than 1, then I'm a happy company. Yeah. Or if X by 1, Y should be little more than 1 to take care of my service levels, I'm a happy company. Now this X by Y type of metric, yeah, is actually a feedback metric on the overall health of the organization. And so you are using artificial intelligence, you're using machine learning, you're getting the distribution patterns, you're computing the optimal inventories, you're computing the optimal throughput rates. Yeah, but all of this needs to convert to a number which the management is going to look and say, this is the number I want to track. And if this number is above this benchmark, I'm happy. And that skill of creating that metric, converting the number, is really the way you're actually going to use AI and ML, or all that you have learned about decision science. Unless that is not done, decision science actually makes very little meaning to the top management. You're then looking at decision science to arrive at end-to-end optimized business strategy, taking feedback signals from after-sales business cycles into account, and look at the cost of doing business. Gentlemen, early on in the early part of this decade, when we used to sell analytic solutions in the United States, and at that point of time, we used to sell standard BI and BW packages. The typical customer, after proof of concept, would come up to us with questions like saying that, all this is fine, but for this particular division, for this particular brand, is there something which is going to tell me the cost of goods sold? Is there something which is going to tell me that 3 months down the line, based on the current inventory status, known promotion schemes, known logistic constraints, warehousing costs, is there something which will tell me 3 months down the line that this is going to be your cost of goods sold? And we actually had to give him a blank stare. I said, no, that's not coming out of this BI system. That's exactly what people are trying to look at. One thing we must remember when we attack any decision science problem, cost of doing business, or the COGS, cost of goods sold, is simply inversely proportional to the profitability of the business channel. So an ability to anticipate that cost of goods sold and therefore give a business strategy is one of the key drivers, key outcomes of a good decision science solution that's expected. You're also looking at dynamic management of channel, factor-wise profitability, considering all parts of the market dynamic. So is it going to be that, somewhere around this end of year, the interest rates are going to decline and the sale of white goods is going to go up? Based on that, how much is my profitability going to be? Are you able to connect those multiple dots in the market? That is another expectation of the decision science solution. So here are, in a nutshell, in a summary, a typical business leader's expectations from a decision support system. He expects the decision support system to have the ability to find the root cause of several multidimensional problems. As we were just discussing in a couple of slides ago, these problems don't have just one dimension. It's first with respect to the market, with respect to the division, with respect to themselves, and there could be many more with respect to the amount of past inventory available. All those with respect to's have to be put together, and you need a root cause solution. So that's one thing you're trying to do. You want to have the management. This is the management's dream product, an ability to flexibly change the line of investigation. So, for example, if it's a mutual fund company and they're first saying that, look, we have equity and debt fund. Then we have within equity we have different types of categories. Within a debt fund we have different type of categories, and within those we have different type of distributors, and within them we have different types of brokers. But I want to start my investigation saying that I will straight away go to the type of broker I'm dealing with. I don't want to look at the distributor. I don't want to look at the category. So I want to flexibly change. So what you're going to do is you're going to have all your future predictive metrics computed along all dimensions. Yet your end user is going to expect some sort of flexibility in the way he's going to investigate the numbers. That is the other thing the business leaders expect. They expect the ability to simulate a future business scenario. Now, there's a very simplistic version of this ability to simulate a future business scenario. It's something like, I don't know, during the budget, how many of you would have simply say gone to a timesofindia.com and said, you know what, here is my salary number, here is my EMI amount, here is the interest rate, here is the expected GST taxes, and let me see what my future savings are going to be. Right? So there's always a savings or a pocket calculator. Now, it's very easy to do when you're just going to, have some HTML page working on 4 or 5 data points to do that. But believe me, senior management in a company and enterprise leadership needs that, and at a much more integrated level with taking into account a lot of complexity. That is a simulation that they expect out of decision science. A very simple example of that is you have companies which are actually, many big companies may have close to a dozen team of chartered accountants trying to forecast what is my cash scenario for the next month. Yeah, what is the cash scenario? It's nothing but about the working capital management. What is my cash scenario, which says, so I know that next month to meet all my account payables, okay, I need to have so much extra cash in hand because there are account receivables, but there are customers who pay late. I have to pay some vendors. There is a standard manufacturing expense. There is a standard office expense. Now, what is the cash management I need? And believe me, guys, these are areas where a whole lot of modern numeric techniques, including artificial intelligence, come in. Let me just give you an example. You could actually say, maybe use artificial intelligence to say what sort of customers are going to pay up late. What is my confidence level to say that these sort of customers will pay up in a 1 month timeline of the credit period? So many people are going to violate the credit period. Yeah. Now that is actually AI and ML. Now look at it. Look at along the various aspects of organization functioning where we'll actually need to use decision science at small component levels. Each individual components will have some sort of decision science peg attached to it, a metric attached to it, and all those pegs will further combine together into another layer to give a complete crystal ball gazing sort of scenario, a simulate a future business scenario sort of ability to the business user. That's again something that businesses expect from a decision support system. They expect the ability to investigate a future outcome. What do we mean by that? Suppose you're running something like a chit fund, okay? And you know that in the chit fund, you actually start making money once somebody invests in your chit fund constantly for 2 years. You're as a head of the chit fund, you're not making money without that. Now, suppose you had many transactions, and you were worried that your sales guy who got the person to invest in the chit fund actually came, invested in the chit fund, but you knew some number of them bought people who used to walk away in 2 months, who walk away in 3 months. Now, based on all those trends, am I going to say that the total bucket value of money that I have after 4 months at any point of time is X% of the total? And that decline of 100 minus 6 is actually being contributed by so and so people. Can I investigate my future outcome? Can I plan for it? These are the sort of decision supports that management actually expects out of a decision support system. So these are a few tools we built at M76. They're called thought chain, thought grid, thought play, thought pin, thought sim, thought tree. I mean, all everything is thought. So we basically thought is our, we believe we are here to reimagine thinking the way people think. So there's a lot of thought in everything. So yeah, thought chains are those flexibly investigative value chains. Thought grids are what we call them the Excel of business. You can actually simulate the health of your business. You can say what happens if production goes up so much by X in this month. Thought play is an area for random experiments. Thought pin actually helps you pin the needle in the haystack. Thought sim does the business simulations we talked of. And thought tree is actually based on a proprietary algorithm. It actually gives you certain decision options. It's a three of options of thoughts. Now, how is the current landscape being transformed? What is happening currently? How is decision science being dealt with in the current scenario? And how is it being transformed? So current scenario, often a lot of the problems that you would like to address with decision science are actually sort of problems that consulting companies address, large consulting companies. And the problem that it's fairly opaque. You often don't know what's being done because it's not being given to you in the form of a software template. So it is done, a report is generated, recommendations are made, but it's not a process you're going to be able to recreate again. That's the problem. Suppose tomorrow your management were to sit alone with the data, it might not be able to recreate the whole process. And that's the reason you might often, in your own company, and believe me, guys, it's not about the most complex things. Suppose in Microsoft Excel, you use certain functionalities which says get or optimize to this number, right? You use some max, min, some correlation functionalities in Excel. Even that intelligent solution is a decision science solution. And if you do it in-house yourself, it's much better because you have control. Next time when the data comes, you know what to play with. Or you should actually have a platform which helps you work with those algos again and again, rather than having a pure opaque consulting. So typically the CXO still sits with reams of information. You should have your own platformized algos. A real decision science platform should actually have the ability to blend functional knowledge with the power of algos. So business knowledge, which I call the value stream knowledge, that needs to blend with the power of algorithms and bringing the power from the tool operators to decision makers. So, a real, a company very good at decision science should not, in fact, have the need to have a lot of people who know R or who know Python or stuff like that. Rather, they should have automated the process enough so that the business decision maker works on it like in a do-it-yourself fashion. So that's the sort of the way a platform should actually work. Typically generating a lot of redundant reports. Rather, decision science would have a system work the way a business leader thinks. Ultimately, the job of the software should be to help the business leader think in the way he wants to think, he wants to investigate, not by throwing a data to him saying, this is my star schema, this is my reporting structure, this is the data for you. In the end, they need to simulate options. There are actually a variety of forms that decision science can assume. In fact, some of those forms are completely unassuming, and you might be surprised to know that these are the places also where decision science is actually put into action. We give you a very nice example. It's legal analytics. This is a very interesting story. In fact, I'll become a little anecdotal for 2 minutes, but you guys will enjoy this conversation. In the United States, there's an article called Section 240A, which allows illegal immigrant to claim clemency. He can state clemency. What is clemency? Typically an illegal migrant is asked to, leave the United States. Yeah. Now there are cases where he can actually apply for clemency. Now he has been illegal. Okay, he is being charged with being illegal, an illegal migrant and person who has overstayed. He can say that in my home country where you're trying to deport me and send me back, there are there is a very poor law and order situation. I can't do much, or if I go there, my finances will be severely disrupted, and now I already have dependents in the United States who are going to be financially hurt if I'm going to leave. So there are a couple of such criteria, okay, based on which the judge, the court, can take a call for clemency and say, okay, though you're illegal, you are now finally allowed to stay back in the United States. Uh, then this is a real case. An attorney spoke to us saying there is a lot of qualitative information. So you can read through all the cases. There's a lot of qualitative information which is available, about how people have applied, what are the cases they have made, and the outcomes are available. Okay, based on this, the claim for clemency has been rejected or has been accepted. Uh, it was actually possible, and we did build a prototype for that. It was actually possible for us to say that based on so and so claims made in a clemency claim, this is the probability that the claim might be accepted, the clemency may be granted, and this is the probability it might not. And this was actually used, to build a decision support system right at the point of entry. So right at the point of time, somebody came and filed his case, it was possible to say whether the case would go through or not, and most importantly, what would be the strategy of the case. Did they need to stress more on the financial aspects? Did they need to stress more on a poor law and order situation in their home country? What did they need to stress on? They're a completely unique application. But decision science, believe me, has many applications because it's about how a leader thinks. It's about how a decision maker thinks, and it's about codifying that thought process. Credit underwriting, yeah, that's another application. So before you have several of Nirav Modi's and such people, is it possible to actually check if they have attempted evergreening? Yeah, which is, have they attempted to move their loans from one bank to another bank, or within the bank from one type of loan application category to another? What is the NPA outstanding? There are several ways to actually strengthen credit underwriting, and decision science can have a very strong application there. Planning of new market entry strategies, it's typically seen as the domain of the standard market research companies, who are going to come out and define, okay, this is my market entry strategy. This should be a market entry strategy. So many people of this socioeconomic category being available here, there. This is the consumption appetite of this type of town, town A, town B. But the fact that you have a whole lot of more data available now, you have point of sales data, you have data on which online promotions have worked, which sort of promotion has worked in which city, what is the future projected income level of a city. So has town B been classified as a smart city? Being a smart city, is it actually likely to graduate in terms of the number of consumers it's going to have? There's a lot of data available, and this data again can be weaved in scientifically into a model to make a new market entry strategy. The last one is what we already discussed, the black sheep impacting profitability. And this is the sort of decision science journey. And in fact, I have just given the timeline, but this could be anybody's journey. This could be your journey as well, as you start going through the pangs of trying to build a decision science solution. And my humble submission to all of you is, please don't get bogged down by some Coursera course. I mean, no grudge, no ill feelings, no prejudice, nothing to support or advocate a course or not advocate a course, but it's about you knowing what you're actually trying to solve. Any standard course available on the internet may not just be the best thing or the solution that you actually need. You might actually go through an iteration like these arrow marks that I have put up here. So roughly, take you through those arrow marks. A decision science, it's often residing in the people's techniques and the techniques that management is going to use. Yeah. Now, a variety of combinations of SPSS and Excel were often used to generate pinpointed solutions. So often in the late 90s, yeah, the managers knew what they wanted. There were some standard tools like SPSS available, And then Excel had some basic functionalities like pivot. So in fact, I remember it was only in the late 90s or early part of the 2000s that pivots became more popular and more comprehensive in Excel. So that is the one thing with which the manager started. But believe me, guys, this is just like engineering. So if you are somebody who's graduated from engineering and you've actually worked on the shop floor, yeah, you would actually say that they would say, get your hands dirty, get your fingers dirty, then you're going to know to handle the machine completely. Guys, data is no dissimilar. Data is exactly like that. And doing a solution first on Excel or on SPSS is actually getting your hands and fingers dirty. And you must do it. Only when you do that, you will actually know the decision science solution you really need. You really need to run after. And you will know the limitations of what happens while doing with Excel and SPSS. You will actually know what you actually need to go forward with. Then you can move over, pure play business intelligence. So, way back in 2012, where I was the retainer consultant to Times Now for the elections, we realized that none of the standard visualizations were actually helping explain an election. And that's where we developed properties, like Spectrum and other properties, which actually explain the election. These are grading algorithms, and they have a visualization attached to it. So what you can do with your own hands is you might just take an A4 and say, this is the way my final visualization should look. Believe me, connecting that visualization to the Excel or the SPSS work or the simple dirty work you've done with your fingers will really help you do a roadmap for what your solution should be. You'll understand what my solution needs to do, how it needs to help visualize in the end. Towards the mid of 2010s, several numerical techniques emerged, and a lot of solutions like the one which I just described a couple of slides before started emerging. So you will yourself then start making some small business solutions. I mean, these solutions could even be something like simple supplier management. Believe me, that is also an area of very important decision science. So you'll actually start producing a lot of these point solutions, point functional solutions you'll start making on your own. And of course, you can platformize them. You can use a platform like ours. You can build your own platform. And then you can actually, in the end, integrate it with future data. What is the data we need from the market? So for example, and believe me, gentlemen, it's just that the buzzwords have caught up now. This science has existed for a while. This is just a renaissance of the science. Way back in the 1990s, it was alleged that a very, very popular French cement company in India could actually predict week by week, district by district, what would be the price of cement bags in those districts. Now, that is essentially important to say that this is the way I'm going to make my market entry strategy. These are the next few products. These are the next few brands. This is the inventory that I'm trying to build in those markets. And, now you have the renaissance because the data is available to you. Previously, the data was the privilege of a few, was scarce to collect, and was difficult to transform. Today, the data is not the privilege of a few. It's easy to collect, and you have tools galore. It's just up to you, how we're actually going to sculpt the solution and create maybe your own Mona Lisa. So that's about it, guys. That is the decision science journey, and I think we've hit the perfect hour. We are at 4 p.m. I'm sort of open to questions now. Yeah, I'm going by the pseudonym Ramesh, so you can reply to me now. You can put your question on chat. Very good question. Are policymakers using decision science support systems, to solve social complex problems? Actually, in the world, yes. In India, I think we've just made a big, and I'll give you the two examples. In Australia, for example, predicting what sort of food consumption, would lead to a different mental health or, a disabled future is being used by a lot of, local governments there to see nutritional advice should go out? What should be the advisory going to people? So policymakers do use that. In India, I think we have just started using decision science even for solving social complex problems. So for example, if you read a lot of the work that is published by the Niti Aayog, they're actually talking of aspiration indexes. They have aspirational districts which are classified as aspirational. So that is also actually an application of decision science. It's a simple grading algorithm, which we showed in the last value chain. Yes, the beginning has been made. The only question is whether people are going to get the right data and the right metric pegs. That is where the real intelligence comes in. But the beginning has been made. While the next question comes up, I can just briefly throw a couple of other insights, of how decision science is pretty active. Sometimes not in a nice way, often, but the very fact that you receive certain mailers, yeah, and certain targeted advertisements from a few of the groups is also a decision science. Now, that's not something that everybody likes, but that is also a decision science. In fact, based on a lot of social development parameters and data collected from Aadhaar, the bureaucracy often grades who is supposed to avail a certain benefit or subsidy. That is also a decision science. I have a couple of questions. I mean, I want to make this a little open forum to make it lively. I'm seeing some other participants as well, Arun. Have anybody of you attempted some simple Excel sheet solutions in your company? I think that is the beginning of the journey. I don't know, anybody may raise hands. What Excel sheet solution, what is the problem you're trying to solve? There's a good forum where we can actually discuss how that would be a good decision science problem to solve and how that problem would actually evolve.
Hi Jay, Arun this side.
Yeah.
So I was earlier working with Lava, and I was kind of leading a team, and so it was a big team, right? So the field force team, and we were kind of involved in Excel based solutions. So what we used to do is we used to project on what sort of expected productivity these people are supposed to get. And basis which what sort of how are we supposed to plan their budgets as in terms of their incentives and stuff. So it was majorly data crunching through Excel, wherein we used to always try out that what have been the past trends, what have been the external factors currently, so how's the growth been going, is there any new product, but it was always a messy thing to do. I mean, we used to work around 5-6 different data sets, and it was always an approximation. So we never derived to a decision science to it, but we always made a way out to make it logical in that sense. So that was it.
Yeah. No, so actually that's exactly the way decision science starts. Now, if I were to say, let's get into some sort of crystal ball gazing. Now, if you're going to say that, let's start with this Excel sheet solution, and how are we going to build it? How are we going to platformize it? Okay. So very crudely put, okay, those 5 or 6 Excels that you put together, okay, they can be very succinctly made as standard transformations, either in an ETL platform or even in a platform like ours, where we're actually putting together a couple of scenarios. So for us, any scenario is a transformation, right? And then what you do is much like a workflow system, right? Takes data from one point, puts some sort of a rules engine on it, and gives an outcome saying send a mail to this person, send a mail to that person. Like a workflow system, you actually need to automate the series of transformations. And in the end, you should actually have some sort of an Excel report which says that these are the 5 or 6 or X number, which is above the benchmark, below the benchmark in terms of productivity. These are the benchmarks for the last 3 months.
Right.
Now, all that after some point of time not only becomes cumbersome to do manually on the Excel, even the process loses some integrity because some data that you pick from here, put there is not there.
I completely agree.
Right? So that's where a numeric a sort of collaboration system is needed. And that's exactly the reason why M76 Analytics actually built the platform. So yeah, what we do on our platform is we have series of scenarios, which you can chain together and say in the end, this is the benchmark I want, and this is the signal that I'm looking for. So that's the way.
That's so. To add to this, so see the variables on every month, they keep on changing, right? So there might be at one point in time there is new competition in market. At one point in time there is a hit running product. So is there a way we can kind of make a decision basis of these variables? I mean, wherein we can change these variables on a monthly basis. And let's say this month the variable is different, and the next month the variable is different. And these variables are not really quantifiable. I mean, I really would not have a data set for a product which has just been launched in the market, or a new competitor which have entered in the market, right? And how do you kind of weigh those variables and put them in a factor to kind of come up to a value or approximation? You get my point?
I get a point. See, there are a couple of things you need to do in this case. One is you can actually look for likes. So many often when you're launching a new product or entering a new market, you look for, is there a like product history before? Was there a similar product? The second thing you actually look for is often surrogates. What I mean by surrogates? Surrogates are substitute information points which are not as accurate but fairly accurate for decision making. So, for example, if somebody were to launch a high-end coffee shop,
right?
Okay, in a market. Now this is a completely new city. There are no coffee shops before.
Right.
So as a surrogate, he could actually use information like, is there a West Side store over there? What is the average footfall in the store? Yeah. Right? Because he's trying to target the same segment. So if you use likes and surrogates, you can actually put them into your model. The second thing is, which you spoke about, is, a lot of this information actually, is changing from month to month, is often fed into the system. See, the way, you will get a lot of answers for this if you look at the way many of the modern collaboration portals operate. So what happens in a collaboration portal is that a particular customer puts in, so suppose it's a supply network collaboration. There are multiple tiers of vendors. Now you will have one vendor who will put some information saying this is my inventory here as of week ending the 20th October. Another vendor which is having the semi-raw goods, semi-finished goods, he'll say this is my inventory, right? And maybe a sales guy can come and say, based on my feedback from the retail stores today, this is the sale expected next week. So a collaboration portal actually takes everybody's input together.
So you're talking about the bottoms-up approach, right? Wherein
right. So you can actually, yes. You see, you can even use a lot of external data to build a retail sales, but that's a fairly complex process. Now, let me give you an example of a non-bottoms-up approach. Many times banks who have their branches in newer suburbs, okay? For example, you're staying in Bhayandar and, let's say Standard Chartered Bank doesn't have a branch in Bhayandar. Now they opened a branch 6 months ago, and now they're trying to verify, for example, is my market saturated? Am I done with all the number of savings or current accounts I should have had from this locality? Right? Now that cannot be done in a bottoms-up approach. It has to be done by actually going around and surveying. So, we often get requests from small branches saying, can you actually recce this entire locality and tell us this is the potential for savings accounts? Now, again, there you can use some surrogate metrics. You can say that this locality on an average consumes so much amount of electricity. The data is available, but as I said, how you source the data and how you transform it, that will hold the key.
Yes. Similarly, probably they can also use data from their own similar market and see the percentage of market share they are standing at that locality.
Yes.
And likewise, yeah.
Yes, absolutely, absolutely. So it is again the intelligence of how you're going to source and transform the data. Everything will go over there. After
Sure.
you have put that intelligence in place, all you need is a robust and sustainable platform. So that you're not getting tied into the Excel, basically.
Agreed. Thanks, Jay.
Right, right. Manish, I see you had one more question about the investment. Yeah. I'll just answer the question on investments. Now, if you actually start with knowing your solution, and I'll be very honest, I don't have to be speaking as a product vendor always. I've got to be honest about it. See, if you know what is the exact automation you seek, you may even simply combine a lot of openware, freeware tools and build your own solution. It is not heavy investment. But remember one thing, when you're building a light investment solution, you have to accurately know what are the transformations you're making, what is the output you're taking, and what is your trade-off on performance. Because often these solutions won't scale up. And that's where your management would come and say they actually have performance issues, they have performance questions. They want to tweak the solution a little bit. And so, no, I've already done it, coded this way, it won't get tweaked. So if you accurately know what decision you're taking, if you really have the patience on performance, you have some trade-offs in place, it's not heavy investment. But if you're really looking to scale up, you're looking to be flexible, you're looking for performance, well, then yes, then it does call for an investment. Yeah, I have a question from I think Rahul Andrews. How is decision science applicable for small startups compared to large organizations, considering big data is largely generated in large organizations' ecosystems? Very good question, Rahul. Very good. I think uh, yes, decision science is applicable to smaller companies, smaller startups, especially if the startups are dealing with selling their information in the e-space. They're going to electronic sales. They're actually going to collect a lot of data. And a lot of the freeware analytics may often not help them navigate with the data. So, for example, the first company that I mentioned about, the e-commerce company, the company when it started was an unfunded startup, but it yet had volumes and volumes of data. And then they actually did not know how to engage and go ahead with the data. They started engaging us. So even for a small company, it's possible. They may not buy the most expensive tool, yeah, but they will have the data. An e-commerce company. So for example, even let's talk of, even in India, today there are many small niche garment retailers who have their own garment manufacturing, and they're actually trading purely on the net because they cannot afford the retail channel sales costs and the account receivables, which is going in the standard supply chain. These companies do generate a lot of data. They generate data on which of their Facebook ad was clicked, which of their Google ad worked, which ad on a particular bought how many visitors, how many visitors coming from a particular site or a particular affiliate actually were notorious for returning goods. They have a lot of data. So data is useful for smaller companies. It's useful for startups. Data is also extremely useful for manufacturing companies. I mean, and they may not be necessarily those big data companies, but manufacturing companies have now started collecting a lot of process information. What is, so for example, if it could not even be a manufacturing company, it could be a small store, but dealing with frozen goods. Yeah. And they're actually trying to say, at what temperature do I maintain the freezer? Can I have a decision point on that? You will even have companies which say that, so a couple of years ago, we were dealing with India's, largest frozen meat importer, and they had very important decision points to take. They said we import meat from all over Europe, but only meat, which is going out through so and so port in Europe is the one which is logistically feasible for us in terms of the cost. So he had all the data. He had years of inventory data. He had years of imports data, years of sales data, years of pricing data. He was not that typical big e-commerce company, but yet he had all the relevant data which he needed to take a decision. So one takeaway I think we should all have is that decision science is not necessarily related to big data, but it's related to data transformation. Wherever you have data, you need to transform it. Decision science is in there. It's not necessarily about big data or about a big company.
Thanks, Jay. That helps.
Hi, Sarang. Thanks. Yes, one story of a company we worked with, which sort of really benefited from data science. So we actually, worked. We'll not give the name, but we worked with one of the largest asset management companies in India, and it was actually a company that was solely giving a lot of flexibility to the retail channels to fix their commissions. Now, it's very interesting. The commissions for typically the mutual funds that you buy are fixed as upfront commissions and commissions that are based on the longevity, how much for how many months or years you're parking your funds with the asset management company. So there was a time when a lot of the individual brokers or distribution channels had the freedom to set their upfront commissions and their trailing commissions. Trailing commissions are commissions that are paid out every month to you, for to a broker for a certain customer being with the company. So there was a time when there was very little control on those upfront and the trailing commissions. And what used to eventually happen is you actually had a lot of users, a lot of brokers who would churn out a customer. So there would be a broker assisted churn, So they would say, what, you come here, you invested in this asset management company for 2 months. Now go to this other asset management company. It's good for you. The returns are better. You don't know. He goes and earns another upfront commission there, and he's got something more lined on his pocket. But this actual, the first asset management company is lost, and maybe even the customer has paid a certain price through some exit load or entry load or whatever. This practice was so difficult to track because there were crores and crores of transactions and thousands of brokers. So this was really a case where there was complex and voluminous data, and actually a lot of big data processing had to be brought in for the purpose over there. So we actually helped them narrow down on a month-on-month basis as to which were the end customers as a consequence of the brokers through whom they were engaged, who were likely to churn off earlier than a year. And then, we enabled them to take corrective action on that. So that was one of the most important cases. We also worked with another company, which is again starting at the exact opposite end of decision science. It's starting from the MIS end. So they had this MIS in place, okay, but yet the management did not know where the month-to-month EBITDA decline was coming from. It's very important for them to actually plan the finances for the rest of their year. So actually, we helped them track down the month-to-month EBITDA declines, whom they were coming from, and who had actually violated the benchmark for this decline. So yeah, those are two sort of wonderful applications of how one can really benefit from data science. Of course, we do also a lot of work on TV. So far, we have during the elections, we actually help Times Now grade the assembly constituencies and say how strong or poor a constituency is in terms of its leaning, and how it will is that constituency signal something that they should be worried about, a viewer or a voter should be worried about. So that is more of algorithm and visualization. But yes, you can have benefits of decision science across verticals. In fact, I have a question for Manish, if he is still around. Is that why is it that you came up with application of decision science to complex social problems? I mean, what is the motivation? Maybe I can give you a couple of more cents on what actually can be done.
Hello, hi Jay, can you hear me now?
I can hear you, but there's a lot of disturbance.
There's some problem in the phone. So yeah, I have some interest in solving some of the very complex social problem.
Yeah.
It's like one of the problems which always fascinates me is there are those of millions of tons of food which is wasted right in cities, and there are hundreds of people, which are starving, right? Daily. So how can we, add those decision support systems, right, to bridge some of the gap, right? So if the food is available, and there is a, there are people, right, who want to, who need food, right, for survivability perspective. So how can we handle such kind of scenario?
Very good question. I think I have an answer for you. See, one is first, these have typically got to be sense and response systems. By sense, we mean all the data has to be available. And by response, we mean based on that available data, they actually need to be able to give a solution. Uh, I'll give you some live examples of India. You take the state of Chhattisgarh in India. It perhaps has one of the most effective delivery systems for public distribution systems, okay, for food and all that. I mean, even the chief minister has earned a moniker for himself based on the amount of rice that gets distributed. Now, the efficiency of distribution of that state is 92%. Okay. Now, you actually need a lot of sensors. By sensors, I mean effective collection of data on the ground. So, for example, you need to be able to know what is the number of people who regularly come and enroll for your Manrega, the Mahatma Gandhi National Rural Employment Guarantee Scheme. So, are they actually, because it is likely that these people who are deprived of some food are going to come and enroll over there. You even need to have counts of data like how many of the children are registered for midday meal schemes, right? So actually, if all that information is put together, you can have some sort of a nourishment or a nutrition index for almost at the block level, which is below a district. At the block development level, you can have a nutrition or nourishment index. Based on that, actually governments should be able to plan logistics and supplies of food. I believe that the Indian government does realize this and has started taking some steps in that direction in a very different way. So I'll give another example. I think last year, a lot of the fertilizer subsidy, the farmers, was connected to the POS systems. Yeah. So they actually could go to the point of sale, pay the full price, and then know that this farmer is eligible for this subsidy, and therefore the subsidy is given for them. I think if the government's sensor system, that is point of sale system or automatic live information collection systems, get a certain level of penetration, certainly a lot of these social issues can be handled. So there is a way out. And I think there are isolated and siloed cases of attempts being made for that.
Correct, because if you look at the advancement of AI and ML, there is a tremendous amount of efficiency which is being built in all the supply chain systems. If you look at the way Amazon .com is operating today, right, in terms of the supply chain, it is phenomenal. But none of those efficiencies or scientific thought process is getting into solving any social complex problems. So that's also one of the large gaps. A lot of the things are only getting utilized in the enterprise, where there is a commercial, interest.
Let me just forewarn you. All this excitement after of solving social problems will also be a big debate on the privacy. After some time, you'll come and say my privacy is being violated.
Right. Yeah. So that's also a big problem in commercial world also today, right? With data protection law becoming very forceful. That's being discussed very heavily in all the BFSI segment. Sure. Thank you so much. Yeah, this is really helpful. Yeah.
Thank you.
Jay?
Yes, Ramesh.
Yeah. So what I suggest is, I think most of what we will do is, there are a few more people who wanted to be, but they could not step in. But there is we've kind of captured some of the highlights. So we may get some, we'll figure out a way to kind of share that with them, and we might get a few more questions from them.
Yeah.
And maybe that we can kind of take it separately, right?
Sure. I'm open to another Q&A session. That's perfectly all right.
Yeah, fine. So again, for the group, anyone else having a question, or can we wind this up with Jay right now? I think Jay, I think we can conclude this session for now. We will separately circle back with you in terms of some more we expect, because a few more people who would have some questions, and we kind of will share that separately. If there is a short follow-up session which is required, with you separately,
Sure.
we'll
Absolutely.
Right. Otherwise, thanks a lot, Jay. Thanks a lot for the session. It was extremely useful.
Thank you.
Thank you.